In this example, we need to solve the equation 2 times log to the base 5 of x equals log to the base 5 of 49. Well, what type of equation do we have here? It's a logarithmic equation, and I just have two terms, both of which are logarithmic terms. So I want to solve this using the one-to-one property of logarithmic functions that says if log to the base b of x equals log to the base b of y, then x equals y. To be able to use this property, the first thing is the base of the logs have to be the same. Is that the case up here? Yes, they're both base 5. And then the coefficient of each logarithmic term must be a 1. Is that the case here? No, I have this 2 in front of my first logarithm. The one on the right has a coefficient of 1, but not the one on the left. So I'm going to have to deal with this 2. And to do that, I'm going to use the power property of logarithms. I'm going to be going in the direction from right to left. So if I have a constant p times log to the base b of m, that p can be moved up and become an exponent on the m. So that's exactly what I'm going to do here. My 2, I'm going to move it up, and it's going to become an exponent on the x, so I'm just going to get x squared. So now I'm just going to have log to the base 5 of x squared equals log to the base 5 of 49. The coefficient of each log term is now a 1, so I can use the one-to-one property. So since log to the base 5 of x squared equals log to the base 5 of 49, we know that x squared has to equal 49. So now I've gone from a logarithmic equation to a quadratic equation. This is a very simple one. I can solve it by taking square roots of both sides. So x equals, don't forget the plus or minus, the square root of 49. So x equals plus or minus 7. Are we done yet? No. We started with a logarithmic equation, so we must check for extraneous solutions. And we do that by plugging our answers into the original equation and make sure all the arguments of the logs are positive numbers. So let's check x equals positive 7. So I'm going to get 2 times log to the base 5 of x, which is 7. Is that a positive number? Yes, keep going. Equals log to the base 5 of 49. Is 49 positive? Yes. So I have shown that x equals 7 is not extraneous. And since this is a fairly simple equation, I can finish the check. Remember, the 2 goes up and becomes an exponent. So I have log to the base 5 of 7 squared equals log to the base 5 of 49. Well, 7 squared is 49, so this is a true statement. So I know x equals 7 is a good solution. Now I need to check x equals negative 7. Plug it into the original equation. 2 times log to the base 5 of x, which is negative 7. Is negative 7 a positive number? No. So that says x equals negative 7 is an extraneous solution. So what's the answer to this problem? X equals positive 7. There is just one solution to this equation.